College Algebra, Topic 5.2. We'll solve for x on these exponential equations. The method we're going to use is by finding common bases. The common base for 9 and 27 would be a 3. 9 would be a 3 squared, whereas a 27 would be a 3 to the third power. The x minus 1 still remains x minus 1, and the 1 minus x still remains 1 minus x. But since we have powers raised to powers, these two can multiply with each other, and we'll get a 2x minus 2. Here, exponents will multiply with each other, and we'll get 3 minus 3x. Since our bases are now the same, we can equate the exponents and say 2x minus 2 equals 3 minus 3x. From here, I'm going to add 3x to both sides, which will cancel that one, but make this 5x. I'll add 2 to both sides, which will cancel this one, and make the other side 5. Then dividing both sides by 5, I get x equals 1 for a solution. Okay, for number 4. I want to take the reciprocal of both of these, so we'll have whole numbers. So this will become a 4 and a 2. And this will become 4 to the negative 1, all still raised to the negative x plus 3. This will become 2 to the negative 1, all still raised to the 2x minus 1. Now, the 4 here, we're going to, the negative 1 here, we're going to distribute here. So we'll have 4 to the positive x minus 3. And the negative 1 will distribute here. So we'll have 2 to the negative 2x plus 1. Now, the bases are not the same. We have a 4 and a 2. The common base will be a 2. So I'll make a 2 here and a 2 here. 4 is 2 to the second power, and the exponent is still x minus 3. And here the exponent is still negative 2x plus 1. Now I have, again, powers raised to powers, so we're going to multiply. So we get 2x minus 6. And over here we'll still have negative 2x plus 1 as the exponent. Now we have common bases, we can equate the exponents. So this will be a 2x minus 6 equals 2x plus 1. Now from here, I can add 2x to this side, which will cancel, and 2x to this side will give me 4x. Adding 6 to this side will cancel, but adding this 6 to this side will give me 7. So when I divide by 4 on both sides, we'll get x equals 7/4 as a solution. Okay, number 5. Number 5, to get common bases, I'm going to convert this decimal into a fraction. So this will be 10 raised to the x, and this will be 1/10. And I'm taking the reciprocal of this, which will make it 10 to the negative 1 power. And now we have common bases. So I have a base 10 here, base 10 there. So I can equate the x to the negative 1, and I have my solution. Number 6. Once again, let's convert this to a fraction. So we'll have 5 to the x equals 2 over 10. Well, 2 over 10 simplifies down to a 1 over 5. And if I take the reciprocal of 1 over 5, I'll get a 5 to the negative 1. So now we have common bases. And so I can equate the exponents, and x equals negative 1. Okay. Number 7. Here, I can't get the bases to be the same because this is a variable and this is an 8. But I can attempt to get the exponents to be the same and go backwards. So let's make this. Let's keep this x to the third, and let's say this is 2 to the third. And now my exponents are starting to look alike. I have negative 3 here, but I have a positive 3 there. To make this a negative 3, I'll take the reciprocal of the base. So we'll get a 1/2, but now to the negative 1/3. And now that the exponents are the same, negative 3 and negative 3, I can equate the bases, which is x equals 1/2. Okay, same thing here. 81. I'll convert 81 into 3 to the 4th power. And we have a negative 4 as a power, and a positive 4 here. I want this to be a negative 4, so I'll take the reciprocal of the base. So we'll get a 1/3 here and a negative 4. And now, since the powers are the same, negative 4, we can equate the bases. So x equals 1/3.